Hello everyone, the teen engineer here. Let's tackle another physics problem involving linear momentum. So let's read it. A 48 kilogram body is moving in the direction of the positive x-axis with a speed of 285 meters per second. When, owing to an internal explosion, it breaks into three pieces. One part, whose mass is 8.5 kilos, moves away from the point of the explosion with a speed of 443 meters per second along the positive y-axis. A second fragment, whose mass is 3.5 kilos, moves away from the point of the explosion with a speed of 301 meters per second along the negative x-axis. What is the speed of the third fragment? Ignore effects due to gravity. And how much energy was released in the explosion? Now, that second question allows us to determine that this is an inelastic collision, since there is a change in kinetic energy. So there is a change in energy, which means that there is energy that was lost, and here they're asking you how much energy was released in the explosion. So it has to be inelastic. So let me just draw how it should look like. So this will be before. Let me make that a bit bigger. Oops. Okay. So yeah, we have that. 48 kilos, so this one must be 48 kilos. In the direction of positive x, so this should be the direction, 285 meters per second. It breaks into three pieces. So after, I'm going to draw each piece separately. One part whose mass, so this one will be 8.5 kilos. Moves away from the point of explosion along the positive y-axis. So here, 443 meters per second. The second fragment, whose mass is 3.5 kilos, so that's the second one, moves away from the point of explosion with a speed of 301 meters per second along the negative x. So negative x is here. That would be 301. What is the speed of the third fragment? And how much energy was released in the explosion? Okay, so this third fragment, we already know that, since at the beginning it was 48 kilos, and then one of them was 8.5, the other was 3.5, then if we subtract 48 with 8.5 and 3.5, that would give us the mass of the third fragment. So minus 3.5, that would be 36 kilos would be the third fragment. 36 kilos, and we don't know its speed, so I'm just going to leave it blank. So let's start. So initial momentum is going to be equal to final momentum. Initial momentum, so mass times initial velocity, is going to be equal to, and then we can add those up. So this one, I'm actually going to use unit vectors in this one to make it easier for us. So this one, I'm going to leave it like that actually for now, but after that I'm going to use unit vectors. And then here is going to be 8.5 times VF plus 3.5 times VF, and then plus 36 times VF. So they all have different final velocities. I just want to make sure that I'm clear with that, so I'm just going to number them. And so the initial, now we can start replacing. So that would be 48 kilos times, and then I'm going to use unit vectors here, so that would be 285 meters, 285 I meters per second. It's going to be equal to 8.5 times, and that would be a 443 J meters per second plus 3.5, and this one will be times negative 301 I meters per second plus 36, and then we're just going to keep this one at VF3. So scroll down. Oops. Let's multiply everything. So simplify everything. 48 times 285 is 13,680 I kilogram meters per second is equal to 8.5 times 443. That will be 3,765.5. That would be kg. So kg meters per second. That's J. So I gotta keep that. 3.5 times negative 301. So that would be minus 1,053.5 I kilogram meters per second plus 36 times VF3. So we can only addition and subtract. We can only add and subtract the i's with the i's and the j's with the j's. So 13,680 I, we have to add that with the 1,053.5. So these two, I'm just adding these two numbers together, which gives us 14,733.5, and that's I. And then we can also bring this J here, but I'm not going to change it. So minus 3,765.5 J, and that would be kilogram meters per second, is equal to 36 VF3. And then we can divide by 36, which gives us, that would be 409.26 I, and 3,665.5 divided by 36, that would be minus 104.6 J. And then that was kilos, so that we cancel out the kilos, so that would be meters per second is equal to VF3. Now that's the unit vectors of the velocity, but they were asking for the speed, and the speed is just the magnitude of the velocity. So we have to do, so speed is just going to be square root of this squared. So you take that squared, all of that, and you add it to, and I'm just gonna remove this, okay, it's a bit too small, so, and then you add it to, and you take this, copy that, take that here, whoops, I forgot to copy that, okay. So take that, copy that, paste that. So you take that here, and you also square that. So squared. So let's do that calculation. And that gives us 422.42 meters per second. 422.42 meters per second. All right. Now they asked also what was how much energy was released in the explosion. Let me just how much energy was released in the explosion. So this is an inelastic collision. So delta K is not equal to 0. So we have to find delta K is what they're asking us. So if we do delta K is equal to Kf minus Ki, that's equal to delta K. So let's find the final kinetic energy. So to do that, we add up all the individual kinetic energies of all the three different parts. So there is there is the 8.5, right? There is the 8.5 at 443. Yeah, 8.5, 443. So that'll be 1/2 times 8.5 times 443 squared, because kinetic energy is equal to 1/2 mv squared, plus 1/2 times the other one was 3.5 and the 301, and so that one was 1/2 times 3.5 times 301. That's 301 squared. Plus, now that we have the speed of the last one, that would be 36 times 422.42 squared. Minus initial kinetic energy, which was 1/2 times, what was the initial? I believe the initial mass was 48 kilos, okay? So 1/2 times 48 times 48. And then the initial speed, I forgot to, it was 285, okay. Times 285 squared. And that should give us the change in kinetic energy, which we're looking for. So let's do all that. 1/2 times 8.5 times 443 squared, plus 1/2 times 3.5 times 301 squared, plus 1/2 times 36 times 422.42 squared, minus 1/2 times 48 times 285 squared, which gives us 225,105.82 joules. And that's the final answer. So let's have a look. All right, that looks great. So thank you for watching. If you like this video, then give it a like. If you want more videos like this, subscribe. And yeah, bye-bye.